Hello, folks. Right, so we've got a new topic today, matrices. You might have enjoyed this with Carrie Ann last year. Let's see if you enjoy it again this time. Right, what are matrices again? You probably remember a variety of operations to do with matrices, multiplying, inversing, etc. But what is the point of a matrix? Well, the formal definition of a matrix is that it's just a grid of numbers. But its main purpose is to describe how we get from one coordinate space to another, e.g. rotating the coordinate axis, enlarging, shearing, or even creating stroke discarding dimensions. So you can see in this example, there's been a bit of a transformation of that triangle, a transformation that swaps the x and the y axis. So if we look here, if you use this matrix, you've seen this before, you can see when you multiply that down, it swaps the x and the y to y and x. Or you could have over here, if you look at this cylinder, has been transformed into a circle. This transformation, which projects a 3D image into a 2D one, discards the z coordinate. If you could get me out of the way here, I don't think I can move me now. So this matrix here keeps the x, keeps the y when you multiply it down, but you mix the z zeros, it just ends up with x, y. Would be the answer that's hiding. Before we start today, these are things you should have picked up from last year. You should be able to add, subtract, perform scalar multiplications with matrices and carry out multiplication of matrices. So have a go at that one. Pause if you like. Oops, oh dear, giving you the answer before we really had to do it. Okay, I hope you've unpaused now. That was the answer to part A. And here comes part B. All right, question 2. We'll read it and then pause the video, please. You should know how to find the determinant of a 2 by 2 matrix. So have a go, pause the video, get the count, and then unpause now, and here's the answer. Okay, you also should be able to calculate the inverse of a non-singular matrix. You might learn how to do it with a calculator, just plug it in and put the power minus on it, it'll do it for you. Or you can use a factor of the determinant. Remember, it's 1 over the determinant. And then you swap those things around. Let's see if you remember how to swap them around. Have a go, pause the video. Okay, on pause, here comes the answer. There we are. Those two diagonals swapped and these changed signs. The 4 and the 1 became 4 and minus 1. And last one here. You should know what a transpose of a matrix is, the AT. If you transpose that matrix, what do you get? Have a quick go. Answer coming up. Nothing. So the column just stopped for the row. There is to it, isn't it? This question's asking us to multiply matrix A and B. There's matrix A and B. See if you can multiply them together correctly. So it's 2 times 3 times that one, those two. Row by column, row by column, row by column. Multiply them line by line. Add the products, form a matrix. Now you're doing it just fine. And so on. See if you get it. And the answer coming up. Hopefully you got C. 2 makes a 6. And then when you do that times those two, you get minus 2 plus 6. That makes the 4, and so on. Hopefully you got those. Remember, your calculator can do it if you can't. Right, it says here, another bit for you to have a go at. So have a pause, find the determinant and the inverse of each of these two. So we did that a second ago. Can you do again? So I'll pause. Well, you pause. And then unpause. And here we have the answers. First one, determinant is 4, inverse matrix that. Second one, determinant 0. Ooh. So it actually doesn't have an inverse. Do you know what we call a matrix which doesn't have an inverse? We should have met it before. We say it's a singular matrix. So let's pop that in. So this happens, we say the matrix is singular. Can we do this on a calculator? Well, yes, the answer is just put the matrix mat A in, and then you put mat A to the -1 in, and yeah, it does. Right, okay, so today's lesson, they should have a handout for this. If you've printed it out, just fill it in as we go along. If you haven't, you'll have to make some notes. So we've got up here reminding us if AB was that, then A equals B to the B inverse. And if B equals A inverse. Fascinating. Right, anyway, today we're going to recap what we've learned about matrices last year. We're going to understand what is meant by the inverse of a matrix. We're going to be able to find the transpose of a matrix, to be able to find the determinant of a 3x3 matrix on our calculator and by hand, and to be able to find the inverse of a 3x3 matrix. It's harder than 2x2. So first of all, let's recall the transpose of a matrix. That's when we switch the columns and the rows. To find the transpose of this, swap the columns and the rows. No big surprise. Look, wow, look at those graphics. The row becomes the column. The row becomes the column. Wow. So the rows and the columns just swap places. Rules you may find useful. A, B all transposed is the same as B transposed, A transposed. A plus B all transposed is the same as A transposed plus B transposed. Interesting. On your whiteboard, have a go then. If this is A, find A transpose A and AA transpose. Try to use your calculator. You can put this in your calculator, transpose. If you have a look at your machine. Little pause there to get my calculator and a chocolate mousse. Right, so let's have a look at the machine. So if you put A in, so you'll have to menu run mode, you'll have to press that F3 key to get the matrix vector thing. Comes up with matrix first normally. So that's a row by column. So 3x2. You have to tell it a 3x2. Then put in the 1, 0, 2, -1, 0, 3. And you've done that. You can exit a couple of times. And then if we get that turn matrix A, so how do we get that? Well, I think we're going to have to press Option, F2, and then you'll see the turn is on F4. So F4, then we have to press Mat, which is F1, and then alpha A times, and then we'll put in mat A, alpha A, and see what happens. See if you get that. I don't know if you can see that. Oh no, where's the camera? And maybe not as sort of reflects it, but it should be what we're going to get here, let's hope. So, can I get that to go back to normal? Let's have a look. Right, so that's what we should get. You might have done it by hand a lot quicker than on the calculator. To moose. And AA transpose, is it any different? So you can put them in the other way around, see if it's a different answer. Wow, it is exactly a 3 by 3. You turn them round. If you remember from doing multiplying matrices, if you've got a 2 by 3 times a 3 by 2, those disappear, don't they? And you end up with a 2 by 2 answer. Whereas here you've got a 3 by 2 times a 2 by 3. So we end up with a 3 by 3. Fantastic. So things to notice. Matrices are not the same. I.e. A transpose A is not equal to AA transpose in general. We know in general that matrices multiplication is not commutative. Both results have the same diagonal sum. Ooh. 1 plus 5 plus 9 makes 15. 5 plus 10 makes 15. Freaky. Right, determinants of 3 by 3s. Determinant, or mod A, or det A, for a matrix A means determines whether it has an inverse or not. So if your inverse, if you remember, 1 over the determinant is part of finding the inverse. So if your determinant is 0, you're not going to get an inverse, are you? Right. So a 3 by 3 determinant, put straight brackets on means we're doing the determinant. We sort of met this when we did those vectors. You remember I called the I, J and the K business. It's the same here, but we've got A, B and C. A is positive, B negative, C positive, and then you find the determinant of what's left when you cross that row out and that column out, etc. So with this question, I'm going to fill this one in. Determinant will be 3. Then we'll cross that row out. I'll do it on there and that off. So we're left with this determinant here. 2, 5, 4, 3. And minus, about that round. Pick a different colour if you like, you know, blue. So we're looking at this one, so it's minus 1. And determinant, cross out that row and that column. So we're left with now 2, 5, minus 3, 3. And then, let's just rub out those. Then we might have, well, we will have plus 4. And it's going to be determinants. You get rid of that column, that row. And we've got 2, 2, minus 3, 4. If we work all that business out, we'll have 3 lots of 6 take 20. Can I do that? Better check. I'm not mental maths, a bit slow. Right, so what we've got there is 3 times minus 14. And then we'll have minus 1 times this determinant, 6 take 15, which makes 21. Then we've got add 4 lots of 8 take 6 is 14. And that, if you work it out, all comes to minus 7. So here we've got a determinant value, so our matrix has got an inverse. So remember over here, if A is singular, the determinant will be 0 and there'll be no inverse. If A is non-singular, then determinant will not be 0 and it will have an inverse. So on your whiteboard, or on the walls, on a nice piece of clean paper, have a go at finding those 3 determinants by hand. Fantastic. I'll have a bit of mousse. Please pause. Okay, you're probably on pause now and dying for the answers. Here we go. Minus 12, minus 416, 0. Could you have done this on your calculator? Answer is yes, you could. So if you get your machine again, if we were like we've got that matrix in from before, or if we've got a 3 by 3 matrix or whatever, we want a 3 by 3, don't we, really, do this, show this up. So if you go into your matrices, you put that, maybe put that last one in. So we want matrix, oh gosh, we'll have to exit a few times. Matrix, put in 3 by 3, enter a matrix, so mention that last one, 4, 2, 8, 2, 3, 3. I'm entering it as matrix 1. Matrix A, 2, 1, 4. So if you enter your matrix, exit a couple of times, and to get the determinant, you have to press Option and F2, and then you'll see on F3 det. So you press det and then press F1 for matrix, alpha A, matrix A, bingo, comes up with 0. And if you can see again, it's all backwards, I think it's pointless me showing you. But should work if you follow those verbal instructions. Oh, there it is. Bit of help. Okay, determinant that you can't use your calculator with. Boo. It's got letters in, so you'd have to do it by hand. So here, where k is a constant, we are given that A is a singular matrix. Find the possible values of k. If we know it's a singular matrix, stop again. If you know it's singular, then you know the determinant's going to be 0. So if we like expand that one out using our tricks, just checking on my sheet before I make a mistake. So we know this determinant's going to be 0. So it's going to have 3 lots of the determinant k, k plus 3, 0 and 2 minus k times the determinant of minus 2, 2, 5 and k plus 3, and then plus 0 times the determinant of, there's no point to this, is there, but minus 2, 1, 5, 0. So that's going to be 0 anyway. And we know all this has got to equal 0. So if you sort this one out, we're going to have 3 lots of ends up as k plus 3. This one becomes minus k, and you end up getting that times that, so that's minus 2k minus 6, and take away another 10, and that's 0, so we know that all this equals 0. Grouping things together, you end up with a k squared, because you've got that business there, so we get 2k squared plus 19k plus 9 equals 0. And if you solve that little quadratic on your calculator, you end up with k equaling minus 0.5 or minus 9. Wonderful. Okay, properties of the determinant. If you're a determinant of AB, then that's equal to the determinant of A times the determinant of B. The determinant of A transpose is in fact the same as the determinant of A. A few more bits. Another interesting fact, if a matrix is square if it has the same number of rows and columns, a matrix is symmetrical if A transpose is the same as A. So if you can swap those rows and columns, you'll still get the same thing. And all symmetrical matrices clearly must be square. Pretty obvious, that, isn't it? Anyway. Right, recap inverse of a 2 by 2. So if you remember doing this, you first find the determinant. 1 times 4 take 2 times 6 gives us, you can tell me, and then when we did the matrix, it's 1 over the determinant. And then you swap these things around. Remember doing this at the beginning of the lesson? So 1 and the 4 swap places, and the other two just change sign. Also recall that A inverse A is equal to A inverse. Why? Well, they're both equal. I, won't they? Because something times its opposite will give you the identity matrix. And if it's a 2 by 2, that means 1, 0, 0, 1. As it says here, why? Because doing a transformation followed by the opposite leaves the coordinate space unchanged, just as the identity matrix has no effect. Makes sense? Inversing 2 by 2 matrices then. If A equals that, find A inverse. The method we used was a specific case of a more general method, which can be used for matrices of any size. So here's the general method. Step 1, find the determinant. Well, we did that before. That's just, or is this a new one? I don't think it is. No, it's just -2 again, isn't it? Step 2, form a matrix of minors m. The minor of each element in a matrix is the determinant of the remaining matrix when the row and column are crossed out. So when we cross out the first thing, top corner, that and its row, what we're left with is just 4. We try that with the others. If we're working out this one, we cross out those and that, and we're left with the 3. Do the bottom one, we're left with the 2. And if we do that corner, we're left with the 1. So the minors, that's the matrix of minors. Let's write that, so that's our minors again. 4, 3, 2, 1. Next step. Form a matrix of cofactors. A cofactor by definition is a signed minor. We simply apply signs to each minor using the follow alternating pattern. So plus, minus, plus, minus, plus, minus. So that's our minors. So the cofactors will be this with plus, minus. So the 4 stays as it is, comes -3, you get a -2, and the 1 stays as it is. Step 4, a bit complicated this, isn't it? A inverse is 1 over the determinant of C transposed. So 1 over -2 of C transpose. So the row becomes the column. And that's our inverse matrix, which is the same as what we were doing when we just said right up here, swap the 1 and the 4, put minuses in front of the other 2. That's what's happened. See? Far more complicated than doing that shortcut, but this is the method that we can use for doing inverse of any size of matrix. If you want to go and do a 10 by 10 matrix, you'd follow this pattern and you could find its inverse. You might be very bored by the end of it, but it would work. We'll stick to 3 by 3 for today though. So doing this 3 by 3, you'll follow exactly the same method. You'll first of all find the determinant, which is a long-winded thing on itself. If we're doing that by hand, that would be 1 times determinant of that, 4 times nothing. That ends up as 1 minus 3, and the determinant of what happens there, then it'd be 0, minus 2. And then plus 1, and you end up minus 8, don't we? And if you work all that one out, we end up with minus 1. Step 2, form the minors. So if you remember, the minors was when we cover up and find the matrix of each term, so that's a palaver. So that one, cross that, what was the matrix of that? Well, we've just done that, haven't we? It's 1. If you're doing this one, you cross that, find the matrix of that, which is, what's in that bracket there, minus 2. And same, that will be minus 8. And then you have to do it again for the middle row. So let me just do this one with you. So you cross that, and then you do the matrix here. So that's nothing. Take away minus 1, so that's a 1. And similar with the others, you'll get minus 2, minus 7, minus 1, 1, and 4. So that's the minus. Then we find the cofactors. So you follow that pattern of plus, minus, plus, minus, plus, minus. So that stays a 1, that becomes a 2, that stays minus 8. So it's plus, minus, plus. So this one will be minus 1, stays the same, change the sign on that one. Then it's plus, minus, plus, so minus 1, and 4. And then our inverse is 1 over the determinant of the transpose matrix, so 1, minus 1, minus 1, 2, minus 2, minus 1, minus 8, 7, 4. Wow! Wonderful. And then you could, if you wanted to, sort that out, divide everything by minus 1. So just call it 1. Oh, minus 1, sorry. Minus 1, 1, 1. Minus 2, 2, 1. 8. Minus 7. Minus 4. Whippity. There you go. And you can do that on a calculator as well, if you remember. Just put in matrix A and then just put mat A to the minus 1 and it will do it without any fuss. But that's how it's done it. That's the program behind it. And in the exam, if you get letters in your matrix, then you do have to do it by hand. So you must remember these steps. So please have a go at this one, not by cheating on your calculator, but by using the methods we've just found. So pause the video, it'll take you a while, but have a go. Some loose for me, there might be a bit left. Right, hopefully now you've unpaused and got your answer. I could have checked it on a calculator, but here's the other steps check. That was the minors. Those were the cofactors. Transpose it and divide it by the determinant, which ended up as a 6. So it's 1 over 6 times that matrix. And that was it, really. Wonderful. Hope you got it. There's the calculator method. It works a lot easier than that. But as I say in the exam, they sometimes throw some random letters in so you can't. Okay, here we've got an exam question. It's got in, like I said, a letter here, so you can't do it on the calculator. You have to do it by hand. So pause the video now if you want to have a go. It's not too tricky, or you can work through it with me if you don't feel comfortable. So part A, so pause if you want, but here we go. Part A, that M will equal, so it's that times the determinant of those. So we've got K ends up there being just -2. And then we've got minus the middle one, so it's minus 1, so it's plus 1. Determinants of that. And you end up with 4. And then plus 1. And then determinant of those 4 ends up as -2. Sorting out all your terms, you end up with -2k plus 2, which is what it wanted us to show. Correct. Part B, the inverse. So this is a palaver. So we start off by finding the minus. So that's the determinant of each of the things when you cover the thing up, so you end up -2, 4, -2. The next row, if you just do that together, it'd be there. So the determinant that's left is -1, take -2. So that gives us 1. And then if you do the others in a similar way, you get these. And then the cofactors, just when you pull plus minus, so it becomes -2, -4, -2, -1, k take 3, and then 3, oh no, wait a minute, no, change to minus, so it's 2k take 3, and then the bottom 1, that becomes k plus 1, and that stays 1. And then if you remember the inverse, it's just 1 over the determinant times the cofactors transposed. And there we have it. Fantastic. 7 marks. Okay, more for you to do. Have another go at those 2 if you can, or just have a go at 1 if they're boring. You pick A or B. Have a go. Do it by hand. Or have a little chat on your calculator. Chat to your calculator. Well, we don't. Have a little go on your calculator. If you press matrix, you have to put that in first. Alpha thingy. Does that still work? I wonder. That might be for the old computer. But all you need to do is put the matrix. Fine. Shift 2. Oh yeah, shift 2. Maths on top of 2. It's just a different way of doing it, isn't it? And then alpha. And the next theta t gives you matrix A if you put it in as matrix A. And then you have to put power button to the power -1. And it should work for you. Have a go. Final interesting keynotes for today. The determinant of a 2 by 2 matrix gives the scale factor of enlargement of area. Remember that from working with Carrie-Anne last time. But the determinant of a 3 by 3 actually gives the scale factor of enlargement of, what do you reckon, goes up from area? 3D? Might have got this one. Volume. The matrix would have. If a determinant is negative, the transformation involves a reflection so that the object and its image have opposite orientations. There we go. Right, exercise 6A has lots of fun in it. Use your calculator when you can, speed things up. But if you've got letters in, obviously you can't use your machine. You want a little bit more practice. Oh, here were those inverse matrix of these. I think so, these last answers, weren't they? So this is what I said, have a go on your calculators. That was A from the last slide. And here comes B from the last slide. Hopefully your calculator just came up with those answers there. Right, wonderful. I think that's enough from me for today. You have a go at exercise 6A and see if you can get into the matrices. Thrilling as they are, it may take a little bit of time to get excited by them, but I'm sure you'll get there. All right, there are from me.